Welcome to lesson 1.5, the language of algebra. Believe it or not, you will use algebra in everyday life. Whenever you try to solve a problem that has an unknown value, you are doing algebra. The problems we did in lesson 1.4, where we were finding an unknown percent of something, that was algebra. It's the use of a formula where you substitute numbers into the formula that helps you get the answer you're looking for. So anytime you have to find area or volume or just any other unknown value like a percent or an increase or anything like that where there's a set way to do it and you substitute your values into that set way to do it, you are doing algebra. That is the language of algebra. Now, algebra is a generalization of arithmetic. Think of that as a standardization. So we standardize math by, instead of you having to think about how do I solve this problem, we standardize it through the use of a formula. Area is defined as length times width. So we know that. We don't have to think about how do I find area every time we have, we need to know how much carpet to buy for our living room or our bedroom, or how much flooring do we need to put in, or how much paint goes on the walls. We can use the formula that we learn in algebra to make it a shorter process for us. So you will be using algebra, maybe not every day, but you will be using it whether you realize it or not. So it's good to understand a little bit about it so that you can go forward as a consumer and know how to solve the problems that arise. So let's talk a little bit about the vocabulary in this lesson. A variable is the symbol used to represent an unknown number. So in early math, you might have had something that looked like 5 plus 3 is equal to what? Well, that is your variable. That is your unknown value. You could have just as easily put in an x, and that would have been a variable in everyday elementary math. That is what it is. It is just an unknown value. So whenever you're trying to solve a problem to find the answer that you don't know yet, that's a variable. A constant is a symbol that represents a fixed number. So in our problem, 5 plus 3 equals x. 5 and 3 are both constants. Now, a term is a group of letters and numbers between operations that represent a value. So a constant is also a term, but this x is also a term as well. So constants and variables are terms, but you're going to run across some problems that look like this. 2x plus 3 is equal to, let us say, 11. This is a term as well. This is simply saying 2 times some unknown number plus 3 is equal to 11. So you have 1, 2, 3 terms here. You have 1, 2, 3 terms here. This number by itself is a constant. This number by itself is a constant. And when you have a constant and a variable together, the constant is called a coefficient. We don't have that on here as a definition yet, but we'll get to it. This constant is a set number. Think of it as something that you know the value of. A constant is any number that you know the value of, and a variable is any number that you don't know the value of. And a term can be any combination thereof. So letters and numbers together, numbers by themselves, letters by themselves, anything in between operations that are grouped together are considered terms. Now, like terms are two or more algebraic terms, so these are all algebraic terms, with the same variables and exponents on the variables. So everything except constants will match exactly. What I mean by that is, if I have 2x plus 3x is equal to 24, let's just say, the 2x and the 3x are like terms because they both have the variable x. that matches, and both of the variables have the same exponent, which is just 1, which we don't write the 1. It's understood that it's there one time. So these will be like terms. So we could actually add like terms. So to do this problem, we would say 2 plus 3 would be 5x is equal to 24. So that would be how you would combine the like terms. You match the variables exactly, and then you add the constant. Now, if this was a subtraction, a minus sign here, then it'd be 2 minus 3. We would be combining 2 and negative 3, and we'd have negative 1x, right? So that is how you would solve like terms. That's how you would combine them. An expression, right? This is an expression. Let me give you an example. An expression is 5 plus 3. Another expression might be 2x plus 5. These are expressions. An equation is when you put expressions equal to each other. So if I were to say 11 plus 2x equals 17. This is an expression. While this is a constant, this constant is also considered an expression by itself when it is a result, because you can always say plus 0 and turn that into an expression. So whenever you have an equal sign, it is understood that you have an expression here and an expression here set equal to one another. And that's what you're going to see a lot of. You might even see something that looks like this. 2x equals 12. These are two expressions. This is 2 times x is equal to 12. And you can always say 12 plus 0 if you feel more comfortable calling that an expression. But it's understood that it could go on and on and on, adding zeros forever. So that is how a single constant can be an expression. And because this has an operation here, 2 times x, this is considered an expression because there is an operation implied, because we know that when we have constants and variables next to each other, that multiplication is happening there. Those are factors. So because of the operation present, this is an expression as well. So let's move on to our first example problem. Our first example says to simplify this expression. And we know it's an expression because there is no equal sign in it. So the first thing to do is to group these terms in an order that makes sense for combining them. So what I'm going to do is I'm going to put my constants first. So I have a 4 and I have a negative 2. So 4 minus 2. So that's this constant and this constant taken care of. So now I want to put them in alphabetical order just because that makes sense to me. I have a y term, so I'm going to put y. Y comes before z. So that takes care of that term. And notice whenever I write them, I write whatever the sign is in front of them because that is the sign of the term. And now I have z terms left. So I'm going to write them just the way they're written. I have a plus 8z and a plus z by itself. Now, whenever you have a variable all by itself, excuse me, it is understood that there is a constant of 1 right in front of it because we are saying 1 times z, whatever the value of z is. It's understood that it's there 1 time. But mathematicians are lazy. So if we don't have to write the number 1, we don't write the number 1. So it's understood the 1 is there, but we don't write it. So whenever you do addition here, it's important that you see that this is 8 plus 1, not 8 plus 0. Because 0 times z would be 0, regardless of what z was worth. So you have to put that 1 there to remind yourself, until you get used to it, until you can see it without thinking about it, that there is the constant of 1 next to any variable that does not have a constant in front of it. So now we can combine like terms. So these are like terms. So we have 4 minus 2. That would be 2. So I can put 2 in here. This does not have any like terms, so I'm going to bring it down just by itself. But these two are just alike. They both have a z with an exponent of 1 or no exponent, depending on how you look at it. 8 plus 1 is 9, so it's going to be plus 9z. And so that would be the answer to this problem. That is as far as you can go, because 3 times y is its own value, and 9 times z is its own value. We don't know what y and z are, so we can't go any further. That's as far as we can go. So let's look at our next example problem. So here we have 3 different problems to simplify. So let's begin with the first one. So here we have 2 expressions grouped together with parentheses. So what I need to do first is look at the parentheses, remember my PEMDAS. I have to look at parentheses first when they're there and see if there's an operation that I can do. These are different terms and they're not being multiplied against each other, they're being added together. So there's not really anything I can do, but remember that this positive sign or negative sign in between implies that there's a 1 right here being multiplied against either of these. So we can get rid of the parenthesis through that multiplication. Positive 1 times 3x just means a positive 3x, and a positive 1 times negative 9 remains a negative 9. So that's all we can do right now to get rid of the parenthesis. There's no operations we can actually perform. Now we can group things together based on their terms. So I'm going to look for constants first. So I have a positive 5 and a negative 9. So 5 minus 9. So that takes care of that one and that one. Now I'm going to look at what I have left, and both of those are x terms. So I have a positive 2x and a positive 3x. Remember that when there's not a sign in front, then the term is positive. So now I can combine. Remember when we have a positive and a negative, we have a subtraction problem. We're actually just combining 5 plus negative 9. Remember our rule that we're going to subtract the smaller from the larger, so 9 minus 5, and then the sign is going to be whatever the sign of the larger number is. So this is, the answer is 4 when I take 5 away from 9, but because 9 is the bigger number, my answer is actually a negative 4. Now I can't combine this with these because these are different terms, that these have x's and this one doesn't. So all I can do is bring down the operation in between. But what I can do is I can look at the constants here and I can combine them. I have a positive 2 and a positive 3. That's 2 plus 3. That's going to be 5. And that variable that goes with it is x. So I want to just show you here how this works. So if I have 2x plus 3x, let's say that the value, I'm going to say that equals 5x. Let's say the value of x is 2. So I can come in here and I can substitute the value of x. So 2 times 2 is 4, plus 3 times 2 is 6, and 5 times 2 is 10. So substituting the same term with the same value gives me a true equation. And that is the whole point, is to make sure that what we're doing is mathematically true. We want what is true and correct. And that is why we can add like terms like that, because we know they're going to be the same operation or the same value multiplied against the constant, and that is going to be the right answer when it's combined or solved. So that is what allows us to combine like terms. So the answer here, as far as we can go, is negative 4 plus 5x. So let's look at our next one. Now we have negative symbols or minus signs on the outside of our parentheses. So we have to insert that negative 1 right there and right there, and then we have to multiply times what is on the inside of the parenthesis. So we have to do the parenthesis first. So negative 1 times 5x is negative 5x. Negative 1 times negative 7 is a positive 7 because negative and negative make a positive. Moving on to this set of parentheses, negative 1 times x is a negative x, and negative 1 times negative 6 is a positive 6. So I'm going to rearrange those with constants first. 7 plus 6. Notice I dropped the plus sign because I wrote it first. That's perfectly fine for you to do so. And now I have a negative 5x and a negative x. So I have all four of my terms, all four of my terms just in order. Now remember, I have a negative x here, so that's going to be a negative 1x. So now I can combine like terms. 7 plus 6, that's going to be 13. And I have a negative 5 and a negative 1x. Because they're the same sign, I can just add the number and keep the sign. So negative 6x. And that would be the answer to this problem. All right, looking at the last problem, we have some constants that are going to be multiplied times what's inside the parentheses. So we have to use our order of operations. 2 times 3x is going to be 6x. So we did 2 times the first number. Now we're going to say 2 times the next number. 2 times positive 4 is a positive 8. Now for this parenthesis, we have a negative 8 on the outside. We're going to multiply that times x. That's going to be negative 8x. Now we're going to say negative 8 times negative 2. Negative times negative is a positive. 8 times 2 is 16. So now we have some constants. So let's put our constants first. We have 8 plus 16 because that's the sign for 16. And now I have a positive 6x and a negative 8x. So first I'm going to combine my constants, and that's going to be 24. And now I have a positive and a negative. So when I have different signs, I subtract the smaller from the larger and keep the sign of the larger. So in this case, the larger is negative. So my answer is negative 2x. And that would be the final answer for this problem. So let's look at our next example problem. All right, so in example problem 3, we have an evaluation problem. And what that means is it wants us to substitute in values for each of the variables that are given. Now there's a couple of ways that you can do that. You can sub in the values first, or you can do the calculation and then sub in the values after and then multiply. I prefer to sub in the values first because it makes it easier to just add constants together when you're done. So one of the things that I tell students to make it easier is to use what I call buckets. Buckets are just parentheses that hold the value of the number for you. So we're going to put a bucket everywhere we have a letter. So I'm going to put a bucket for x, and then we have a parenthesis already. So I'm going to make that a big parenthesis so I can tell the difference between my bucket and my existing parenthesis. You could also change that to a square bracket if that was better for you. And I have the number 2, and then I have a y. So I'm going to put a bucket for y plus 4. And then I have the other existing parenthesis. So you can clearly tell that these parentheses were of greater value, right? Now I have minus sign and a 3, and I am going to make a bucket for z. Now I can put the values for each one of those letters in the buckets that I've made. So x is a positive 3, y is a negative 5, and z is a negative 2. Now I'm going to go ahead, and because of PEMDAS, I'm going to do what's inside this parenthesis first because it existed first. So within that, multiplication happens before addition. So I'm going to go ahead and do the multiplication. 2 times negative 5, that's going to be 3, and that's going to be negative 10 plus 4. And I can actually go ahead and perform this because it allows me to, it's not in the parentheses, but it's like a separate expression. It's by itself. So what this is doesn't affect this until after I want to combine it. So a -3 times a -2 is going to be a +6. Notice how I wrote my negative sign first, then I did my calculation and I adjusted it. If you always start by writing the negative sign, then doing your math, you can change it if you need to. If it remains negative, then you haven't done anything wrong. But if you write a plus sign first, then you have to erase and start over. So that's just a little tip. So now I can finish what's inside this parentheses. -10 plus 4, that's going to be a -6. So I have 3 times -6 plus 6. So this is still multiplication because a constant outside of a parenthesis indicates that we're going to multiply. 3 times -6, that's going to be a negative number, and 3 times 6 is 18 plus 6. So I'm going to subtract 6 from 18 because 18 is bigger. It's going to be a negative number. 18 minus 6 is 12. So my answer is a -12. All right, so let's move on and do some perimeter problems. Perimeter problems might come into play in your everyday life when you need to figure out the distance around something. Let's say that you need to put fence around your backyard and you need to know the total length of the fence. So if you know that your yard is a certain rectangle, then you could very easily do the calculation. So let's go ahead and do an example problem like that. So let's say that our backyard is 25 feet by 38 feet and we want to put a fence around the whole thing, like all the way around, even behind the back of the house. So sometimes it's helpful to draw a picture of that. So we're going to draw a rectangle here. And it is not to scale, it's just an illustration, but this is the grass in the backyard. And it is 25 feet by 38 feet. So to find the perimeter, we have to understand the properties of a rectangle. And when we have a rectangle, these little angles here are 90 degrees. And what that tells us is that they're perpendicular to each other. So that means that this line stops and starts in the same place that this line. The corners are going to be square. And the corners are square, then these lines have the same dimension. So that means that if this is 38, this is 38. And if this is 25, then this is 25. But that is because we were told it was a rectangle. And rectangles have that property of two sets of lines, two sets of sides that are the same dimension. So now we can find the perimeter. Perimeter just means the distance around. And like I said, let's say you were putting in fence around your backyard. That would be how you figured out how much fence you needed. So we would say 25 plus 25 for these two sides, this side and this side. And then we would add 38 and 38 for this side and this side. And a faster way to do that would be to say 2 times 25 plus 2 times 38. Because if you think about it, we've got two sides that are 25 and two sides that are 38. So we could have skipped all of this right here and gone straight to this right here, right? So to find the perimeter of a rectangle, we have 2 times the length plus 2 times the width. That is going to be your formula for the perimeter of a rectangle. So let's go ahead and calculate that. 2 times 25 is 50, plus 2 times 38, that's going to be 76. When we add 50 and 76 together, we get 126 feet of fencing that we are going to need for our yard. So that is an everyday situation where you might have to use perimeter. Maybe you have to figure out how much spray you need to spray the edge of your yard around the curb. and you're told that this spray is equal to so many square feet. You can figure that out. So this is algebra. Technically, it's geometry, but geometry uses a lot of algebra. The fact that there is a formula to solve is algebra, and that it is a standardized formula, even more so. So let's look at our next example problem, and it's about distance. So in example 5, we find that the distance Will travels, or we need to find the distance Will travels if he drives 65 miles per hour for 4 hours. So this is what we call a dirt problem. A travel problem is a dirt problem because distance is defined as the rate times the time. So the speed times the time gives you your distance. And if you squint really hard, this might sort of look like an I, and it would spell dirt. So that's how I remember it, is that we travel over dirt. To find distance, you multiply rate times time. So the distance that Will travels is equal to his speed times the time that he traveled. So 65 miles per hour times 4 hours is going to give us his distance. And when we do the calculation on our calculator, 65 times 4 is equal to 260 miles. Now there's another way that you can do this that will help you, and it goes along with unit conversion, which we'll get into later. And that is to create or to use this just like a ratio. 65 miles per 1 hour. If I could spell hour, it looks like a r. Let's do hour. Times 4 hours. Well, hours on the numerator and in the denominator would cancel. So that would leave you with 65 times 4, which would be 260 over 1. And our unit of measure that remains is miles. We know that anything over 1 is a whole number. So we can just erase that, and the answer is still the same, 260 miles. Or you can use the dirt. It's still the same problem. It's just showing you how to use the unit of measure correctly when you do it this way. The unit conversion knocks out hours because they cancel each other out. And you're left with the proper unit of measure, which is miles. All right, that's all we have for lesson 1.5, the language of algebra. I will see you in lesson 1.6.